Now let's automate the compilation process. So that can help us compile the code frequently and check for errors. We will automate it using Makefile. So here is a brief on the syntax. So the first thing is we need to take care of the tabs. It's weird that we need tabs in specific way. We specify the variables using the variable name and equating it with a variable. In the later parts of the Makefile, you can refer to the variable name using $sign. So Makefile has a set of rules. We specify a target and we have a prerequisite. For example, let's say we are creating object files. So those .o files will be target and the .c or .s file would be the input or the prerequisites. And then we will have the recipe or the set of instructions to convert the prerequisites to target. And we have a phony keyword, so not every recipe needs a target to be, to execute. For example, let's say we want to clean up. So we can have something as clean, keyword clean. And we need to specify them with a phony. And there are some special characters like percentage, which is kind of like a wildcard pattern matching thing. And we have the dollar less than a dollar at the rate to pattern match the prerequisite and target. So let's see how all this works with a simple Makefile. Okay, so we create a file, Makefile, and then we can specify a few things. Let's say we want to specify let's say we can try to do cleanup. So let's say clean. The recipe for clean would be remove .o and that should be it for now. Save it. We have the %.o file, the .o file here, the object file. Let's see, make. Okay, so it removed it. So this one is automated. You need to specify here as well that clean is a command, it's not a target. So you make clean. Okay, now for the compilation. We will have some target files and the prerequisites would be S. We will have C files as well, but for now we have only the assembly file. So this should be ARM EABI GCC %C -o and $@ So this matches all the prerequisites and this matches all the targets. So it will take all the .s file and convert it to corresponding .o file. Now we need to specify, see, for now let's we have a linking step as well. So let's get this thing to compile. It's usually preferable to use the variables. So we want to make our final executable as bare stm32. Can have objects. For now it's just startup stm32 f446 re.o. So this is this object file will be created by that this .s file. Then we can say we have program, and the prerequisites are the objects. This, we use the GCC to link slash O. But we need some flags here to tell GCC what it needs to do. So we would need some flags like target flags and C flags and the linker flags. So let me copy the flags from another place that we need for GCC. So this is about this to tell GCC it's in Cortex M4 what kind of little endian or big endian and all kind of other information it provides GCC. The C flags is kind of what kind of optimization, what warnings it has to provide, and it's also including all the target flags. We don't need any of these things for now. And then we can specify the linker flags. Dollar. We'll have the target flags. So these flags will be used for compilation. These flags will be used for at the linking time. Target flags. This is to tell that we are trying to link. And we'll give the linker file. In our case, the linker file is STM32F446 RELD. STM32F446 RE.LD. And we specify these flags in the command. So for compilation, we have C flags. And for linking, we have the link flags. Okay, let's see if this works. It says 21. All right, so we have this thing. So right, so it's doing things, but now we have error in our linker script. So let's take a look. So it's a 6, 5. Okay, so here it has to be all caps. And right, and we missed colon here. Let's see. Says bin LD. Okay, let's check the Makefile. So it's saying no such files found. STM32F446 RELD. Objects, this is good. And Okay, so let's continue with a little more debugging.